Hi students, how are you? So in the previous class we are completing some of the concentration terms explanation. So continuing that one, in this today's class we will discuss the other concentration terms in this class. So what are the other concentration term here? We can see here mass by volume percent. Mass by volume percent. What is this mass by volume percent? Mass by volume percent means mass of solute present in 100 ml of the solution. Let us see the definition here. Mass of solute present in 100 ml of solution. So we will write that formula like this: mass by volume percent is equal to mass of solute by volume, mass of solute present in 100 ml of the solution. We can write formula like this: m by v percent is equal to mass of solute by volume of solution into 100. If you take this one, m, generally mass expressed in grams, by volume in ml into 100. So we can write the formula like this. So generally where we are using these calculations means, these calculations mainly used in pharmaceutical industries to find out the concentration of the solution. Mainly we are using in what industries? Pharmaceutical industries. Pharmaceutical industries. So this is regarding about mass by volume percent. Okay, so the next one we have another concentration term is there, ppm. So what is ppm means? Parts per million. If the solute is present in trace quantities, we can use the method what ppm only. Clear? So when generally where we are using this ppm? ppm mainly we are using to express the pollutants in atmosphere. Pollutants in atmosphere. And one more we can write here, hardness of water. Hardness of water. Pollutants you can see, air, atmosphere contains different types of the pollutants. The pollutant quantity of the pollutant is very less, means in the trace quantities. So we can express that pollutants in atmosphere by ppm. And one more that I wrote here, hardness of water. Hardness of water because of which one? Hardness of water because of the solubility, salts like chlorides and fluorides can be present in the water. So these chlorides and fluorides present in the water is very less quantities. So that concentration we can express in the form of which one? ppm. Mainly these are the two examples we can say to express the concentration in the ppm only. Suppose I wrote here 4 ppm. 4 ppm means what here? 4 grams of the solute present in 10 power 6 grams. 4 ppm means what? 4 grams of solute present in 10 power 6 grams of the solution, or you can say the solvent. Formula we can use, weight formulas also I wrote here, and one more here, volume also we will write here. Sorry, this we can write here 10 power 6. Now we can see here how can you express this ppm. I already told here, if solute is present in trace quantities, trace you can say very small only. If the solute is present in trace quantities, we can use the method what ppm only. Clear? So when generally where we are using this ppm? ppm mainly we are using to express the pollutants in atmosphere. Pollutants in atmosphere. And one more we can write here, hardness of water. hardness of water. Pollutants you can see air, atmosphere contains different types of the pollutants. The pollutant the quantity of the pollutant is very less means in the trace quantities. So we can express that pollutants in atmosphere by ppm. And one more that I wrote here, hardness of water. Hardness of water because of which one? Hardness of water because of the solubility, soluble salts like chlorides and fluorides can be present in the water. So these chlorides and fluorides present in the water is very less quantities. So that concentration we can express in the form of which one? ppm. Mainly these are the two examples we can say to express the concentration in the ppm only. Suppose I wrote here 4 ppm. 4 ppm means what here? 4 grams of the solute present in 10 power 6 grams. 4 ppm means what? 4 grams of solute present in 10 power 6 grams of the solution, or you can say the solvent. Next concentration term is mole fraction. Generally you can write the mole fraction here capital X only. What is the definition of this mole fraction? Mole fraction we can write it is a ratio. It is ratio of number of moles of one component to total number of moles of all components. Total number of moles of all components in the solution. I'll repeat the definition again. It is the ratio of number of moles of one component to the total number of moles of all component in the solution. We can define what here? Mole fraction. Clear? So let us take here one beaker. Okay. In this beaker here we have to take a solution. You know solution means what here? The solution contains here solute plus what solvent. Solute plus what here? Solvent only. So in this solution, suppose I am taking here A is a solute and here B is a solvent. A is solute and B is solvent. Now I write here N of A. What is N of A? Number of moles of solute. N of A means what? Number of moles of solute. And what is NB? NB is equal to number of moles of solvent. Okay. Now I write here Na plus NB. Na plus NB is equal to total number of moles. Total number of moles. Now I write here XA, mole fraction of A. Mole fraction of A is what here? I will write here XA. Mole fraction of B will write what? XB. Now I will write here XA is equal to NA by XA is equal to NA by NA plus NB. In the same manner, we will write XB is equal to NB by NA plus NB. Clear? According to the definition, it is the ratio of which one? Number of moles of one component. One component is Na. Total number of components what here? Na plus NB or taking. So XA is equal to Na by Na plus NB. XB is equal to NB by Na plus NB. So this is the mole fraction of A, that is XA, and this is mole fraction of B, that is what? XB. Now we want to mix these two, means what here? XA plus XB. Suppose you want to write here XA plus XB. So XA plus XB, you are getting total how much? Means here 1 only. You can add here Na by Na plus NB, and one more you are adding plus NB by Na plus NB. If you do the LCM, what you are getting? Na plus NB. So Na plus Nb and Na plus Nb. Okay, numerator and denominator both are cancelled. You will get what? Xa plus Xb is equal to 1 only. So from this we can write one point here. The mole fraction of solute and solvent is always equals to how much here? 1 only. Mole fraction of solute and solvent, okay, is always equals to how much? 1 only. Is always equals to 1. Okay, from this you are writing here Xa is equal to 1 minus Xb, or you can write here Xb is equal to 1 minus Xa. So these calculations generally in the solutions related problems, sometimes we have to get the formula problems related to mole fraction. So based on the given information, whether they are asking that mole fraction of the solute or whether they are asking the mole fraction of the solvent, we can use this formula. So this is regarding about which one means mole fraction. Next concentration term we have molarity. What na? Molarity. Generally molarity denoted by capital M. Okay, I think you already know the definition of molarity. What is molarity? Number of moles of solute. Number of moles of solute present in 1 liter of the solution. Number of moles of solute present in 1 liter of the solution. We can say what here? We can say molarity. Clear? Now we will write here number of moles means what? We can write N only. Volume of the solution means we can write here V only. Now I will write here M is equal to N by V. What is V means? V in liters. So from this how can you write means if N moles of solute is present in V liter of the solution. N moles of solute present in V liter of the solution, then the molarity M is equal to, you will write what? N by V. What is V here? V is volume. What is N here? Number of moles only. But you know the number of moles formula. Number of moles N is equal to, we will write weight by gram molecular weight. Weight of the solute by gram molecular weight of the solute, that we can say what here? N. What is N? Number of moles. From this you are writing here molarity M is equal to weight by gram molecular weight into 1 by V in liter. 1 by V in liter. From this you are writing here molarity M is equal to weight by gram molecular weight into 1000 by V in ml. 1000 by V in ml. So these are the different formulas we are using for the molarity calculations. Clear? Molarity M is equal to weight of solute by gram molecular weight of the solute into 1 by V in liters. One more we have molarity M is equal to weight by gram molecular weight into 1000 by V in ml. So this is regarding about which one? Molarity. So generally we can say what are the units of molarity means here. You will say here units of molarity. Units is equal to, I will write here mole per liter. Why mole per liter? What is N? Here what is mole? What is V? Volume. So that is you can write here mole per liter. So you can write here one more point also. It depends on temperature. Molarity depend on which one? Temperature only. Now here we can write the different formulas related to this molarity calculations. Okay, I will write one formula here. Molarity M is equal to 10 into G into 10 into D into X by gram molecular weight. Okay, so what is D means here? Here you can write D is equal to density, and you will write here what is X is equal to, you can write here weight percentage. Weight percentage. When we are using this formula means if the density is given, weight of the solute is given, okay, then we are using this formula to find out the molarity of the solution. And we will write one more formula also. Molarity M is equal to 10 into x into specific gravity. 10 into x into specific gravity by, you will write here gram molecular weight. Means what? If the weight percent is given, same weight is x like this only, here x also what? Weight percent only. If the specific gravity is given, okay, then what is the formula using? 10 into x into specific gravity by gram molecular weight. So these formulas useful for the objective questions. In that question, suppose they give density and weight percent or specific gravity, okay, we are using this formula. So okay, and one more here, another formulas also we have to discuss related to which one? Molarity. Okay, molarity of the mixtures. Molarity of mixtures. Molarity of the mixtures means what here? If the two or more solutions is mixed with different molarities. Two solutions are there. We are mixing these two solutions. We will get a final molarity of the solution. In that case, what we have to do here? We want to use the formula. Okay, this formula I will write here. Okay, M is equal to M1 V1 plus M2 V2 plus M3 V3 and so on by, you will write here V1 plus V2 plus V3 and so on. Suppose if here two mixers are given, you can cut it the formula up to here M1 V1 plus M2 V2 by V1 plus V2. Or suppose three solutions are given, we can extend the formula like this. So this formula we are using when if the two solutions are mixed with different molarities and different volumes, the resultant molarity of the mixture can be identifying by using this formula. So this is regarding about which one means molarity. So the next concept in the molarity is dilution concept only. What is dilution? Dilution means adding of water. If you add the water to any solution already with you, there is some changes we have to observe here. So I want to take one beaker here. In this beaker already one solution is there. The solution molarity is M1. What is the solution molarity? M1. And the volume of the solution is how much? Means here V1 only. Molarity of the solution is M1 and volume of the solution is what? V1. The volume of the solution in the first case it is up to here only. Okay, now what I am doing here, I want to add some water. I want to add water. You know why? Because dilution means we are adding water. Whenever you are adding of water, then what will happen here? If you want to add the water, then what happened here? The volume of the solution is what? Increases only. The volume of the solution is what? Increases. The new volume of the solution I will write here V2. The new volume of the solution is what? V2. And we have to find out what is the molarity of this final solution, or what is the molarity of the solution we have to find. Okay, so in this case we have to go through the concept, which one? Dilution concept only. So initial molarity V1, volume already we have V1. Now the adding of water, then what here? Volume of the water will increases. When volume of water increases, what will happen? Molarity. Is there any change in the molarity? Let us see here. So here you know one formula, molarity M is equal to N by V. Molarity M is equal to what? N by V. Upon dilution, what happened here? Upon dilution, what happened here? Volume increases. Volume is what? Increases. If volume increases, then what happened here? Number of moles. Volume increases. If the volume increases, what decreases here? Molarity decreases. So number of moles is what? Constant only. Number of moles constant. So from this you will write here M by V is equal to N. From this you can write M by V is equal to constant. Why constant here? Sorry. MV is equal to N. MV is equal to N. So what is M here? M into V is equal to, I write here constant on. Constant. Why constant? Number of moles is what here? Constant. Now I will get the formula M1 V1 is equal to M2 V2. M1 V1 is equal to M2 V2. So this is the formula we are using. In what concept means here? Dilution concept in the molarity only. In some cases they will give molarity of the solution and volume of the solution. First solution, they want to prepare that solution in V2 ml. Then what is the final molarity of the solution? We maybe get one question like this. In some cases, so they giving a molarity and volume they are giving, and M1 giving, V1 giving, M2 giving. Sometimes they asking here volume, and some cases they asking here volume of water. Volume of water must be added. Volume of water must be added is equal. We can use the formula. Which formula means V2 minus V1 ml formula you are using. Clear? So these are the formulas we are using in what concept means dilution concept in molarity. What is the formula you got? M1 V1 is equal to M2 V2. What is the volume of water can add? The volume of water must be added is equal to V2 minus V1 ml. So the next concentration term is molality. What is molality? Number of moles of solute present in 1 kg of the solvent. Again I am repeating the definition. Number of moles of solute present in 1 kg of the solvent is called as molality. It is denoted by small m. Molality small m is equal to, we will write like this, N by W in kilograms. What is N? This is number of moles of solute. And what is W here? The W is what? Weight of the solvent. You already know N is equal to weight by, means weight of solute by gram molecular weight of the solute. From this you are writing molality is equal to weight by gram molecular weight into 1 by W in kilograms. W in kilograms. From this you are writing the formula molality is equal to weight by gram molecular weight into 1000 by W in grams. So what is the weight? This is the weight of solute, and this is the gram molecular weight of the solute, and 1000 means it is the weight of the solvent only. So this is the formula we are using for finding which one? Molality. So let us see the units of this molality. Units of molality will write here mole per kilogram. Mole per kilogram you are writing. Why here? Number of moles is you are writing mole only. Weight always in what here? Kilograms. So we will get what is the formula here? Mole per kg. Now here we can take a okay, molality. Molality does not depends on temperature. Why here? If any volume factor is there, definitely depends on temperature. Here there is no volume factor, so molality does not depends on temperature. We can say it is independent of the temperature only. Okay, so this is regarding about which one? Molality. Clear? What is molality? Number of moles of solute present in 1 kg of the solvent. What is the final formula you got? The final formula molality is equal to weight by gram molecular weight into 1000 by W in grams. So units already we discussed, that is mole per kg, and we can say it does not depends on temperature. Does not depends on temperature. So the next concentration term is normality. So this normality concept is very, very important in objective questions. Particularly we maybe get the questions and psychometric calculations and equivalent concept and all. Compulsory we are using a normality concept. So what is normality? Normality we can define like this: number of gram equivalents of solute present in 1 liter of the solution. Number of gram equivalents of the solute present in 1 liter of the solution we are calling which one? Normality. So normality can be denoted by generally capital N only. Normality will write here normality N is equal to N by V in liter. But here what is N here? N is equal to gram equivalents. N is equal to what ma? Gram equivalent weights. So N is equal to, we are writing here weight by gram equivalent weight. Weight by means weight of the solute by gram equivalent weight of the solute. Now we can convert the formula like this. N is equal to weight by gram equivalent weight into 1 by V in liter. 1 by V in liter. So now we can convert that liter into ml. So we are getting the formula normality N is equal to weight by gram equivalent weight into 1000 by V in ml. So this is the formula to find the normality of the solution. So what are the units of normality? The units of normality is gram equivalent weight per liter. Gram equivalent weight per liter, and it depends on which one? Temperature. It depends on temperature.